Assalamualaikum warahmatullahi wabarakatuh. My name is Fatuna Kimapala, as usual. Today, I make a volunteering video about how to use Shape Dissolve. But before that, I must make a claim that I know how to use it from the assistances video and actually from one of my fellow classmates in CCIT class. Now I'm going to show you how I'm using it and what is the dimension that I use. Actually, it's the same with my fellow classmate, but the density is different. If you look at my circle here, geometry list, initially there was nothing here. It will be blank, white blank page. It was none here. There's now box 4, box 5, box 6. This box 4, box 5, box 6 is the one that I created. So I can create this type of shapes, which is, if we can get it, it's consisting of three blocks. One blocks with the first blocks with the third block is the same. We call it the same shape, the same dimension, but the middle is different. The box for properties, let me show you, is this. And the box 5 properties is this. And the last, the box 6 is this. Now, this is just the name. 4, 5, 6 is just the name. You can change it. But I will call this 1, 2, 3 block to become the first block, the second block, the third block. Now, what we will do after making up the dimension of the block, use before this, it's just a block. There is nothing small block or big block. It's just one big block. What you need to do to make it like this is go to Bash Mesh. What will you do in here is actually setting up the minimal coordinate. I'm setting up only the X because I put it in the geometry preparation. As you can see, I put it 0 and I put it 2.3, then I put it 0.3 also. So in geometry and best mesh, I put it 1.1, 1.0, 0.001. Why I put it like this? Because we need one step forward to make the water inlet come. And then the max coordinate is 0.7999 or 0.7999, 799. With the max coordinate in Y and Z, 2.0.2 and 0.2. And the box mesh properties. The box mesh properties is when you want to visualize the box, the water inside the box, the air inside the box, you want the shape to become sensitive. What I mean is that these small blocks here make it many, because this is the sensor that they will give you where's the pressure concentration is and where's the pressure low concentration is. Why is that so? Because just like integration of the area, as much as you can get the small box, as much as you can get the result of the response. And by this, I make it 100, 110. 100 at X, 100 at Y, 100 and Z. Now, setting up the boundaries, the box mesh boundaries, the X minus phase, which is this, make it inlet. The water or the air, the fluid will come through that. And the outlet one is the X plus. As you can see, the axis is right here. Now, let me go to generate mesh. Generate that mesh. Setting up the mesh location. It's up to you. Where do you want to set it up? But generate this mesh. I have doing this generate mesh and it will become like this. I've been doing this. It takes around 1.5 minutes to 5 minutes. It depends on your device. Then go to the check mesh, checking the mesh. If the mesh is good, then it will say mesh okay. Then comes to the model or simulation. We got the shape, we got the dimension, we got the boundaries, we got the layout, we got the sensitivity. Now, in simulation model, make it simple. If you want to advance, go advance then. But this time I will go simple, which is steady state. The time is steady state. It's not transient. The flow compressibility is incomprehensible. That means the density across the box is constant. Then the flow regime is subsonic. With the turbulence, I'll get laminar, not turbulent one. Also make it single phase. So it will become quicker and more detailed. Then comes the fluid properties. Actually, this is, I'm sorry, pardon, my apologies. Before that, apply the model first. Then comes to fluid properties. This is actually just with what you're liking. I'm going default here. The fluid is air. The density is 1 to 1.225. Then the dynamic viscosity is this, etc., etc. You can see. Setting up the boundary condition, choose inlet, then you choose velocity because I want to find the pressure at the outlet. You choose velocity inlet, and they will ask you the reference value. For this experiment, I use 20. Then you come to the outlet. The outlet, choose outflow. The result will be seen next in video. Do not touch this initial condition. This is for advanced. Then operating condition, do not touch this also. That's the CFD pre-solve, which is the condition that you must set. If it was in day 5, it will become intention and initial thinking about the problem, also be conscious. Now to CFD solve, which is go to the time terms. As you can see, it's steady state also. But go to algorithms, let it be like this, then run solver. This is where the specified of the detailed things you must know because the number iteration is better. As many as number iteration you do, it will take a longer time. But if you want to take a smaller time, just decrease it to 500 or 200. But it will become more or less accurate. Pardon me, less accurate than the many iteration. With this, I'm going to use actually. I need to go fast. I choose 250 iteration. Now that iteration has been set, we just need to run the solver. So you can see there's the time 20, 21, 24, 26. That's the iteration I'm doing. Now before that, I'm going to show you the graph. I stop this floating height video. Now as you can see, the iteration has been finished. Then I will show you too the my whole screen to be exact. So you can see this graph. This graph shows stability. Before it showed the high pressure. Then it will come to the stability. This graph shows the momentum residues and the time second. As more time as we can get, the momentum residues become stable. Now, how to find the pressure concentration in this thing? Go to CFD post, then click the paraview. Wait a minute. Wait a second, actually. Then click apply. Then you will get the pressure drop spread. It seems like 20 meter second of velocity in air is very big for only 4 meter radius box, only 4 meter length box, or not even 4 meter, it's less than 1 meter as I can remember. Now you can see there is some red dot here, red dot there, and blue dot here. That's actually how the pressure is concentrated. Now we can see the inside by using the slice. Press the slice, then make it Y normal. After pressing Y normal, then press apply. That's how the pressure is defined when Y normal. Now let's see if it's Z normal, Z normal. Apply. There you can see also where is the angle that the pressure has the most power. And that's it. That's for how to use CFD solve. Sorry for my few technical problem. And if I use the wrong word, I apologize. Wassalamualaikum warahmatullahi wabarakatuh.